What if I told you every internet device you own is sharing the same IP address? Thanks to IPv4 exhaustion, we've been using duct tape solutions like NAT for years, slowing down your connections and complicating networks. But IPv6 changes everything. With enough addresses for every atom on Earth and built-in security features, it's revolutionizing how we connect. In this video, I'll break down IPv6's game-changing benefits and show you how to decode those intimidating addresses in seconds. IPv4 can provide about 4 billion IP addresses. So even if it may seem huge, it's not enough to keep up with the growth of the internet. To extend its lifespan before migrating to IPv6, several mechanisms have been created. We have CIDR, which saves IP addresses, thanks to better distribution. In addition, it makes routing much easier. Then there is VLSM, which is a technique to better manage IP addresses, just like CIDR. In fact, VLSM, we can see it as an extension of CIDR. The difference is that CIDR is used more at the internet level, and VLSM is used more within a network, i.e. a local network. In general, it finds its place on small network segments, such as point-to-point links. And there is NAT, which allows any equipment on a private network, therefore non-routable, to access the internet using a single public IP address. And like that, thousands of systems can hide behind a few public IPs. Its three solutions only delay the exhaustion of IPv4 addresses. But that won't prevent IPv6 from one day completely replacing IPv4. In fact, many companies have already started this migration. For example, internet service providers. If you look on your box at home, you should have an option to activate IPv6 if it is not activated by default. IPv6 features. An IPv4 address is encoded in 32 bits, which corresponds to just over 4 billion IP addresses, and an IPv6 address is on 128 bits. That's so huge that it's equivalent to an unlimited number of devices. Since to saturate the system, more than 667 million billion devices connected to the internet would have to be placed on every square millimeter of the Earth. This time, the IPv6 will have a hard time being exhausted unless you colonize a new planet. For example, planet Mars. IPv6 has several features that make it very interesting. Among these many advantages are, of course, and this is why it was created, a much larger address space. That alone improves a lot of things, like better accessibility and flexibility, better aggregation of IP prefixes, which are advertised in routing tables. This makes it possible to limit their numbers. The routers will therefore be more efficient and plus scalable. It allows you to do multi-homing, which gives you the possibility of being connected to several internet service providers in order to improve the connection. It offers the possibility of auto-configuration. The plug-and-play option is more extensive, and it has simplified mechanisms, which make it possible to shorten IPv6 addresses. Because let's face it, these addresses are like a very long time. Another advantage of IPv6 is that headers are simplified, making IP packet processing faster and more efficient for routers. We also gain in security and mobility what we didn't have in IPv4. For example, IPsec is mandatory in IPv6, which makes the internet much more secure. IPsec enables private and protected communications over IP networks. To do this, it uses algorithms that allow data to be transported safely. The last advantage that could be found in it is its flexibility to transition from IPv4 to IPv6. That is to say, the ease of migrating from IPv4 to IPv6 very smoothly. For this, there are several protocols, and also a solution called the dual stack, which allows a migration to IPv6 very easily, while being 100% compatible with IPv4. IPv6 addresses are represented as a series of 8 16-bit hexadecimal fields, separated by 2 small dots, as you can see here. This is much longer than in IPv4. Fortunately, there are several mechanisms that allow you to shorten these addresses. For example, the first zeros in a field are optional. 010F can be written as 10F, and a field that contains 4 zeros can only be written with 1 0. Here is the simplified address with this mechanism. And that's not all. It's also possible to group a series of zeros by 2 small dots. Then this process can only be done once in the address. And here is our IPv6 address, shortened. Is it much easier to read? IPv6 supports 3 types of addresses depending on its use. We have Unicast addresses, which are used for point-to-point connections. We have Multicast, which identifies a group of interfaces. Traffic from a multicast address is destined to multiple destinations at the same time. And we have the Anycast type, which are virtual addresses that point to one or more physical addresses. Unlike IPv4, broadcasts, which send traffic to all devices on the same network, no longer exist in IPv6. We have seen that an IPv6 address is a 128 bits long and consists of 8 fields of 16 bits, each, which are delimited by colons. Each field contains a number in hexadecimal format. In this example, for this address, the first 3 fields contain the site prefix, that is to say, the network that is given to the company by the supplier. The next field is the subnet ID, which is what is defined by the network admin. This is the private topology, which is what is internal to the site. And the 4 fields on the right most is the interface ID, which is either automatically configured from the MAC address of the interface, or is manually configured in EUI64 format, which we will detail in more detail in the rest of the course. For more clarity, we can abbreviate our address. 0CD7 becomes CDs. We took away the first 0. C18 becomes 18, and the series of zeros in both fields has been replaced by 2 small colons. The prefix of our address, i.e. the first 3 fields, is used for packet routing. This is the network address. An IPv6 prefix is written like this. As in IPv4, the CIDR notation is used. That is, with a slash at the end of the address, followed by the length of the prefix in bits. The site prefix of our address is 48 bits. These are the first 3 fields. Those who are located, the most left wing. The network address in IPv6 can therefore be written in this way, with the CIDR notation. And for better visibility, you can compress the zeros to replace them with 2 small dots. Now, if we want to include, in addition, the internal subnet, which is 16 bits, well, the prefix of subnet would be written like this. The 64 bits of the subnet prefix are broken down. 48-bit for the site prefix, and 16 bits for the subnet ID.